In section 12.2, we're going to be looking at surface area of prisms and cylinders. So first of all, what is surface area? The definition is pretty high tech. It's literally the area of the surfaces or the faces of a polyhedron. I have the sum of the areas of the faces because sum tells you to add up all of the areas of all of the faces. Remember, faces are your flat surfaces. And if you have a polyhedron, it's nice because you're adding up the areas of polygons, whether it's rectangles, maybe some regular polygons like a pentagon or a hexagon, probably for the shape of the base. But we're just literally adding up the areas of all the faces to find surface area. Starting out, some more terms here. When you're talking about prisms, we know that prisms do have two bases, and they have to be the same shape. Like here, we have a hexagonal prism, okay, two hexagons for the bases. This would just be a rectangular prism, kind of your box shape. Really, all the faces are rectangles here. Here we have a pentagonal prism. There are two pentagons for the bases. But you always have two bases for a prism, and those could be any polygon. And then your lateral faces, if you think about it, what are the shapes of the faces that connect those bases? What is the shape of all 6 of these faces, all 5 of these faces that connect the bases, and actually every face here? Those are always rectangles, right? So with any prism, you're going to have two bases that could be any shape, probably regular polygons. Remember the formula for a hexagon, pentagon, regular polygon would be 1/2 ANS. And then you have a bunch of rectangles to add up, which the area of those rectangles is just base times height. The base of the rectangles ends up being like the side length of the hexagon, and the height ends up being the height of the prism itself. Okay, so two bases, lateral faces are always rectangles, and those connect the bases. And also the number of lateral faces is going to be the number of sides on the bases. Here we had a hexagon, 6 sides on the base, and obviously 6 rectangles going around. With a pentagonal prism, there are 5 rectangular faces connecting those bases. Another little term that you should be familiar with is that you may have oblique solids today. This is when the lateral edges are not perpendicular to the base. This is an oblique triangular prism because it is sort of slanted. We can talk about slant height versus actual height is going at a vertical or a perpendicular. So oblique solids do not go to perpendicular to the side. When we talk about actual height, that is at a perpendicular. Slant height would be at the sort of diagonal. This would be your right or regular rectangular prism, but if it had been tilted, it would be oblique. Alright, let's get to finding some... Oh, one more term here, sorry, before we go to surface area. If you talk about this term, a net is a flat or two-dimensional representation of the faces of a polyhedron. You probably remember this from when you were younger. Like, you took a shape probably like this, you cut this out, the outside, and then all of these lines here, that's where you fold. And I hope you can picture, if you folded on all of these lines, what would you get when you fold this solid up? Well, you get a cube, right? It has these 6 square faces there. Something like this, it's a flat representation, a two-dimensional representation of an actual solid. Sometimes you might remember when you were a kid and you did these, they had these little tabs for you, and you could like tape or glue along these. Well, if I cut the outside out here, and then I folded along this square, and folded up these 4 triangles, you can imagine this would be a square pyramid, and all of these points here would sort of meet at the top vertex of that pyramid. And finally, what kind of solid would you get here? I see these 5 rectangles. I have 2 pentagons. These would be my pentagonal bases for a pentagonal prism here with the 5 rectangular lateral faces connecting. So a net is a flat or two-dimensional representation of a polyhedron. Alright, let's do our first example where we're actually finding what is the surface area of this rectangular prism, basically a box, with a height of 3 centimeters. I'm going to label this as 3 for height. Length is 6 centimeters and width is 8 centimeters. Length is 6 centimeters, width is 8 centimeters. Okay, well, first of all, if we're doing surface area, you're going to need all of the faces. How many faces do we have total on a rectangular prism? You should be thinking there are 6 total faces. There's a front and a back. Those are the same size, same dimensions. There's the top and the bottom. Those are again the same size or same dimensions. And then the left and right faces, there's 6 total faces. Left and right would also be the same dimensions. So let's break it down into all of the parts. Let's do the left and right faces first. And I'm going to do these in blue squiggles. They're the same size. Now the dimensions of those left and right sides are 8 by 3. Okay, so the area of those rectangles is 8 by 3, but we have 2 of them. So 8 by 3 times 2, which is really 24 times 2. So right now I've got 48 sitting there on the left and right areas, and that would be centimeters squared. What about this face in front here, which would also be the same as the face in the back? The areas would be the same here. The dimensions of those rectangles are 6 by a height of 3. Right? 6 by a height of 3. So 6 times 3, and there are 2 of those. So that's really 18 times 2. Looking at 36 centimeters squared. So now I've done the surface area of 4 of those faces, but I've also got the top and bottom here, which will have the same area. Now the dimensions of these bottom and top rectangles are 6 by 8. And again, I have 2 of those. So 48 times 2 would be 96 centimeters squared. Let me just check these all real quick. Okay, looks good. What's my total surface area? I gotta add up the areas of all the faces. I've done all 6 faces now. So I add 48 and 36 and 96. And took me a bit on the calculator, but I got 180. This is surface area. This is the area of all of those flat surfaces or those faces. So it is centimeters squared. There's my total surface area. Okay? So no real formula that I'm giving you, because you should know how to find the area of rectangles in this case and add them all up. No big deal. Okay? So there's a rectangular prism example. What about when I have some sort of regular polygon for the bases? Checking here, I do have 2 hexagons as bases, and then it would be 6 rectangles going around the outside, right? Because this is a hexagonal prism. Again, find the surface area. Notice it is a regular right hexagonal prism, meaning this hexagon is regular and all the sides are congruent, which is helpful. Okay, first of all, let's do the hard part. These hexagons themselves are going to be a little tricky, so I have 2 hexagons that I have to find the area for. 2 hexagons. Now remember, what is the formula for area of a regular polygon? A regular polygon was 1/2 ANS. Okay, if you remember that formula, that would be our formula we're using for the regular hexagon. However, I do have 2 of them, so I have to do 2 times 1/2 ANS. I'm going to need the apothem, the number of sides I have. It's 6, it's a hexagon. And the side length, it looks like I do have the side length, is 12.8. But I need this apothem, the apothem here. So I'm going to put that center, I'm looking at the top hexagon here. This is what I need as my apothem, meeting at a right angle to that side. I'm going to draw in a radius here. Now remember, when you draw in that apothem, you've now split this side in half, so 12.8 divided by 2 there, so 6.4 feet for this side length. Now if you remember, a hexagon is one of our special right triangle situations because 360 divided by 6 gives you a central angle here of 60 degrees. However, that 60 degree is split in half, so 30 and 30. This is a 60-degree angle. Okay, I know that the dimensions of, or like the, I guess, visual of this is a little bit off because we're looking at it from above. This triangle would look more like this. And I have 6.4 here. I have a 60-degree angle right in here, 30-degree angle up here. This is the short leg of this 30, 60, 90 right triangle. If you remember, all I do to get the long leg of that 30, 60, 90 right triangle is multiply by square root of 3. The apothem, the apothem then, is the 6.4 times square root of 3. I now have this value, okay, with that 30, 60, 90. By the way, you could also use Pythagorean theorem since this entire triangle is a equilateral, equiangular triangle. You would know that the hypotenuse is double that. You could know that from the shortcut, or because all of these sides are congruent, so you would know that's 12.8. You could use Pythagorean theorem, and you'd still get 6.4 squared root of 3 for that long leg. But at this point, I am ready to figure out the area of both hexagons. Remember, I did 1/2 ANS for each hexagon, but there's 2 of them. 2 times 1/2, that's just 1, so I can ignore that there. So really, I'm just doing apothem times number of sides times side length. Apothem, I have 6.4 square root of 3. That's what we just talked about here. Number of sides, it's a hexagon, so 6. The side length of the hexagon was this 12.8. Alright, let's see what I get. 6.4 square root of 3 times 6 times 12.8. And I'm getting 851, I'm rounding to 2 decimal places, 0.34, and this is area of those hexagons. Right now we're at feet squared. But the other thing that I have, I mean, I did my 2 bases, and that's cool, but there's 6 more surfaces to add up here. I have 6 rectangles. The good news is all of those rectangles have the same dimensions. So I'm doing 6 times, what is the area of each of those rectangles? Well, each rectangle is 12.8 times a height of 7, right? Because the side lengths of the hexagon is 12.8 by a height of 7. So what is 6 times 12.8 times 7? I'm getting 537.6. Again, this is area, so it's feet squared. What is my total surface area? Now that I've added up every face on this hexagonal prism, both hexagons, and the 6 rectangles, I'm just adding these together. 851.34 and the 537.6, and I get 1,388.94. This is area, and it was units of feet, so feet squared, total surface area. And notice I just did SA for surface area here. Okay, so I added up every single face and added up their areas. The next thing we're doing today, right at the beginning I said we're doing surface areas of prisms and cylinders. So now I need to do the surface area for cylinders. We're going to come up with a formula here. Now cylinders, of course, they have 2 bases as well. But what's the shape of the bases of cylinders? The shape of the bases of cylinders are, of course, circles. And the lateral area of a cylinder is this curved surface here. Okay, so I'm going to come up with a formula. Well, the 2 bases are circles. What's the area? Because I'm trying to come up with surface area, right? What is the formula for area of a circle? Isn't a circle's area pi r squared? We can always remember that because area is unit squared and the radius is squared here. Pi r squared, but wait, there's 2 circles. So pi r squared plus another pi r squared, this is actually 2 times pi r squared. 2 pi r squared, it's 2 circles. So I have that. Now picture this lateral surface. If you made a cut right here in the cylinder, and if this was made out of paper, let's say, if you made a cut here and you rolled this thing flat, okay, you unrolled that cylinder, whether this was like a tin can or like a Pringles can or something, if you were able to do that and roll it flat, what would you get? Well, wouldn't you actually get a rectangle? It looks something like this, right? Here's your bases, and if you made a cut here and laid that flat, you get a rectangle. So I need the area of this rectangle. Now the height of the rectangle just comes from the height of the cylinder, and I'm just going to call that h. The real question is, what's the length of the base of this rectangle? Well, where did that come from? The base came from being around this circle, right? I'm laying it flat. Well, what is it called when you go around a circle? That's the circumference. So this distance, this base here, ends up being what the distance around the circle was, and that's circumference. Circumference formula is 2 pi r. So the area of this portion, this rectangle, would be 2 pi r times h, right? Base times height. So that is 2 pi r h. And in total then, if I want to come up with the surface area of a cylinder, I'm going to do 2 pi r squared, the 2 base circles, plus 2 pi r h, circumference times height, which will give me the area of that lateral face. I'm going to just write this on the next slide here. Okay, here it is. Surface area of a cylinder is 2 pi r squared, so that's the two circles, and plus 2 pi rh, which was the area of the rectangle when you unroll it, the lateral area. That's what I wrote here. Surface area is two bases, 2 pi r squared, two circles, plus the lateral area is the 2 pi rh. It's that rectangular surface when I unroll it. Okay. So let's do an example here. Cylinders are kind of nice because you have a formula you're following. It's as simple as that. Find the surface area of the plastic covering a rolled up poster you just bought. Okay, so we just bought this poster. The height is 36 inches and the radius is 4 inches. What is the surface area? Okay, well, we got two circles at the top and bottom. Each of those circles is 2 times pi r squared. And the radius of the top circles is 4. Plus, and then 2 pi r h, remember, was 2 pi r is a circumference when this rectangle is unrolled times the height. 2 pi, the radius, again, is 4. The height of that cylinder, of that poster, is 36. I can go to my calculator right away. I can simplify a little bit. I can do, like, simplify this term here. 4 squared is 16. 16 times 2 would be 32 pi. And then here I can do 4 times 36 times 2 and get 288 pi. And then I can just add 32 and 288 together and say my surface area as an exact answer would be 320 pi. But most likely you're going to just get a decimal, and you could actually get a decimal just immediately if you want to do 2 times pi times 4 squared plus 2 times pi times 4 times 36. And either way, I mean, if you do this or this all in one step, surface area of that cylinder is 1005.31 to 2 decimal places. Now this is area of that poster or the plastic covering it, so inches was my units squared for area. And that's how I find the surface area of a cylinder. I've got one more example of that for you. Finding an unknown variable, which can be a little bit trickier. Find the height of a cylinder, so we don't know the height, with a surface area, though, of 262.64 centimeters squared and a diameter of 7.6 centimeters. Okay, let's see. We've got a cylinder. I'm trying to look for the height. The fact that they gave me surface area, I know I need to use the surface area formula for a cylinder, which is 2 pi r squared, because there's two circles for the bases, plus 2 pi rh. Remember, this is the area of that rectangle. 2 pi r is the circumference of the circle, which ends up being the base of the rectangle times the height. Let's plug in what I know here. I know the surface area. It's the 262.64. Let's plug in what else I know. 2 times pi times, do I know the radius? Oh, okay. Diameter was 7.6, right? So just divide that by 2. If the diameter is 7.6, the radius is 3.8. I just divided that by 2. So 3.8 squared. Continuing here, plus 2 times pi times the radius of 3.8 times height. And I don't know the height. I'm trying to find the height, so that's just h. Alright. Let's figure out what this term is. And let's figure out what all this is in front of the h. Okay, so right now I have 262.64 equals, that first term is 2 times pi times 3.8 squared. Alright, I'm going to round this portion to 2 decimal places. I'm getting 90.73 plus. Now I'm going to do 2 times pi times 3.8. So I'm doing this much, but that's the h term. I'm getting 23.88, actually, h. Okay, I'm solving for h. So actually I'm going to subtract 90.73. Get rid of it here. I'm going to do 262.64 minus 90.73. I get 171.91. This term was gone, equals the 23.88h. Whew, and now divide by 23.88. So I'm dividing that 171.91 divided by 23.88. And finally come up with a height of, accurate to 2 decimal places, it's 198, so 7.20. And the height would just be a measurement. It looks like we're in centimeters here. There we go. So also solving for an unknown here. Today you're finding the surface area of prisms and cylinders. If it's a prism, you just take the areas of the two bases, whatever formula you need, plus the area of the lateral faces. Those are going to be rectangles. For a cylinder, you take 2 pi r squareds for the two circles plus 2 pi r h for the lateral area.